In the last video, we have made a simple DNA simulation where we have cations flying out and we have nucleotides forming hydrogen bonds. This is pretty adequate for a simple DNA simulation. However, we would like to make some changes. We're going to start with changing the creation of the cations. So I'm going to create a cation prefab, and the number of cations I would like to have. This is going to be in the simulation manager, and I'm going to keep the number of active cations in cation control as a static variable. What I'm going to do is every update, we're going to check the actual cation count and compare with the cation count of the simulation manager. And if it is less, we're going to create a new cation using the cation prefab. There you go. Okay, it keeps creating because we forgot to increase the cation count. There you go. Yeah. They seem to be unaffected by the temperature. And we are getting some errors. Null reference. That's because we don't have rigid body assigned. So we're going to set the rigid body with get component rigid body 2D. Now we can change the number of cations. Now we also have to include what happens if there is more cation than that we want. So we're going to be finding cations with cation controller, and we're going to destroy its game object. And decrease the number of cations. Yeah. Now, because we don't want less than 0, it gives an error. We can put cation count in a range from 0 to 100. So we can change it as we want in the Unity Inspector. The next part, I'm going to be doing the same thing for a strand. So we're going to control the number of strands and sequences using a list of sequences, or we can change the name. Let's call it oligos. It's going to contain sequence information as a string and the game object reference to the whichever strand that is on the scene. And we're going to keep them in an active oligos variable. We can't see that in the inspector because we didn't use system serializable. That is going to let us access to this class. So every update we're going to go through if any of the oligos or any of the oligo class, its strand is empty, then it's going to create using the prefab. So we have to define a prefab strand. prefab. We can enter a sequence, then nothing is created because we forgot to add a strand prefab. There you go. Too many. That's because we didn't assign the Oligo's game object or strand. A game object is better. Yeah. What I do is I delete, press del, it becomes null, and it quickly creates that one. So we can create whatever you want at the beginning or during the gameplay. Now I'm going to include a check for the strand controller. It's going to check every update whether it has been referenced inside active oligos. If it is referenced, then it's all good. If it is not referenced, that means that it is removed, so it will be destroyed. So now we can create and destroy during the gameplay. Let's change to a shorter DNA. We can increase the number of cations to help. Now what the cations do is they annul the repulsion between the phosphates so that the strands can come together easily. And the temperature separates them. Now in the next part, I'm going to change distance joints with hinge joints because they come with some angle limits. So we can define an angle limit. So in this case, about 40 degrees angle limit is, I think, enough. That's because when the DNA folds on itself, it creates a loop section that is minimum of 3 nucleotides. It's very rare that it can be shorter than that. So what we are going to do is we're going to change the distance joint with hinge joints. It seems like we need to add the position of the last game object, last nucleotide. That's basically because hinge joint doesn't have a distance feature, so the moment of creation, whatever the transform is, that distance it tries to keep. So we need to define its starting position. Now you can see that the DNA can't fold on itself. That's because the angles between nucleotides are now limited. In the next video, we will build a user interface to control cation count and temperature. We will also build a live hydrogen bond counter to visualize the double bond formation. Thank you for watching, and please subscribe to see more videos.